Okay, here is the answer key to the quadratics test that you just took. Number one, the answer is 2. This is a simple, straightforward sum and product problem, sum and product of the roots. Remember to memorize these formulas, negative b over a, and the product is c over a. You can also write these down on the formula card. Number 3, same thing, sum and product of the roots, except now you are given the sum and product and you need to find the equation. So you need to work backwards to set it up. And you see that you need to multiply everything by 2 to end up with 2x squared plus 6x plus 4. Because when you divide, for example, 4 divided by 2, you end up with 2. Number 3, here you have, they give you both roots. Here's your quadratic equation. You're looking for b because it is b, the coefficient of x is k. You need to find what k is. So you work backwards. You take -1 and 2, you plug it in for r1, r2, add them together to get the sum of 6. Then when you plug the sum back into the negative b over a sum formula, you need to negate 6, which gives you -6. The answer is 2. Factor completely. Remember the 4 methods of factoring: extract, GCF, difference of squares, trinomial factoring, and grouping. So here we're going to do extraction, and then we unfoil. That's trinomial factoring. The beauty of multiple choice is you can always go through and you can just multiply these. You could have foiled, then distributed the negative x to see which one would have given you this original equation. Number 5. Here you're going to factor by grouping. And as you can see, you extract the GCF from each binomial, and you take x squared minus 4, pull that out. And this is a difference of perfect squares, so you have to factor that again, giving you 2 as your answer. Number 6, the roots of the equation. Here's your quadratic equation. It doesn't specify which method to use. You could try to factor. Of course, I use the quadratic formula, or you could use completing the square. So as you can see, here's your solution. -7 plus or minus radical 73 all over 4. Number 7, again, you're going to solve for the quadratic, solve using the quadratic formula. The only difference between number 6 and number 7 is that number 6 is in standard form and number 7 is not. So you need to subtract 5x, subtract 4, and that would give you your coefficients 1, -5, -4. And here's your solution. Number 8. Whenever you have a question like this, asking what kind of roots they are, imaginary, real, rational, equal, you know you're going to use the discriminant, b squared minus 4ac. So we end up with 153. Because it's positive and it's not a perfect square, it is irrational. Okay? Number 9, solve by completing the square. You must solve by completing the square. If you did not complete the square and you still got it correct, you lost half credit, just like you would on the Regents. Reduce everything by 2, x squared minus 3x minus 1/2, plus box, moving the constant to the other side. The way we get the number in the box is b over 2 squared. b is -3. -3 over 2 squared is 9/4. Add fractions to get 11/4. Take the square root of both sides. And as you can see, we write our final answer with a shared denominator of 2. Number 10, we need to factor first, right? You want to solve for the quadratic, get the roots, 5, -4. Then you plot those points, 5, -4, on the number line. We need to choose 3 test points for the 3 intervals. So we choose one number that's less than -4, so we'll go with -5. We see -5 minus 5 is a negative answer. -5 plus 4 is a negative answer, and a negative times a negative is positive. Is a positive number less than 0? No, it's false. Our test point will be 0. So we plug in 0 here, plug in 0 here, we end up with a negative times a positive is a negative. Is a negative less than 0? Yes, it's true. Finally, our test point here will be 1 to the right, 1 unit to the right of 5, so we'll try 6. 6 minus 5 is a positive number. 6 plus 4 is a positive number. Positive times positive is positive. Is a positive number less than 0? No, it's false. So as you can see, we have a conjunction. It's false, true, false. We use open dots because it's only less than, not the equal to piece. And finally, we write our answer like this: -4 less than x less than 5. This is a compound inequality, and we shade between the 2 points. Number 11, here you could have just plugged it in the calculator. Remember, the less than shows the graphing below the diagonal line. Another thing you could have done is you could have realized that, hey, because a is negative, right, -x squared, the parabola is upside down, right? That doesn't really narrow it down because all your answer choices has an upside down parabola. Well, how about this? Y is less than, so therefore you shade underneath. The answer, or option A, is shaded above the parabola. Option B is shaded above. Option C and D are both shaded below. Confirm your position with the calculator or factor for the roots. So we factor, we get x times x minus 3 equals 0. The solution set is 0, 3. There's 0, there's 3. The answer is C. Okay, now for the extra credit. Use the discriminant to determine all the values of k that will result in the equation x squared minus kx plus 4 equals 0 having equal roots. This is the key, equal roots. You must know that when the discriminant equals 0, you have equal roots. So let's find out all the answers, all the values of k that would work. Well, when we plug in, right, a is 1, b is negative k, c is 4, you plug in to b squared minus 4ac, and you set the equation, or you set the discriminant equal to 0 because of the equal roots thing. So we get k squared minus 16 equals 0, and you could solve by factoring the difference of perfect squares to give you -4, +4, or you could take the square root of both sides, which also gives you plus or minus 4. And that's why the extra credit has two answers here, to positive and -4. Finally, this extra credit. The homeowner wants to increase the size of a rectangular deck that now measures 15 by 20. The new deck cannot be larger than 900 square feet. If the length and the width are to be increased by the same amount, find to the nearest tenth the maximum number of feet that the length of the deck may be increased in size legally. So here's our new deck with 900 square feet area, with the length increased by x and the width increased by x. So we're going to plug all that into our area formula. Length times width equals 900. You must FOIL x plus 20 times x plus 15 to get x squared plus 15x plus 20x. We subtract 900. Sorry, 20 times 15 is 300. Subtract 900 from both sides. We end up with x squared plus 35x minus 600 equals 0. Now we have standard form, and we have our coefficients 1, 35, negative 600. So we plug everything into the quadratic formula, and we end up with a positive answer and a negative answer. We must reject the negative root because that doesn't make sense to have negative length or negative width. So the final answer is 12.6 feet is how much we increase the length and the width by, And there you have it. Best of luck.